Okay. Hi, Angelica. It's Ethan. I'm here to explain the idea of finding a percentile for a sum using the central limit theory for sums. Yeah. So what we're gonna do is we're gonna look at example 2 here. This is the one we did the other day. We did A and we did B. So let's work on number C here. Number C. I'm doing great start. So what let's first talk about is what exactly is a percentile. So if someone tells you x is in the 90th percentile, and that t is looking kind of funky, 90th percentile, they're essentially just saying x is greater than 90% of the values. And that goes for 50, 60, doesn't matter what this is. They're just saying x is greater than y percent of values. This is just the fancier, more confusing way of saying it. So let's look at this statement. So in this case, it's asking for the 90th percentile of the sum of the 39 ages. So we're looking for to be more specific, the sum of x that is greater than 90% of the values. So what that means is, first, we need to know how that doesn't make sense. What we can do is we can draw a normal distribution like I've done down here, and ignore that. You're getting a sneak peek of the answer, but we could draw a normal distribution right here with 0 in the center. And the question is, okay, we need to figure out what sum of x is greater than 90% of the values. Remember, every one of these dots is a sum of x. We're trying to figure out which one of these dots is greater than 90%. Well, another way of kind of saying that using this graph is if we draw a line here, well, if this value, we'll call it z because this is a normal distribution. If we've got a value z here, we're looking for when this blue area is equal to 90% or 0.9. So this is essentially saying the same thing. But in this case, in this case, we can't figure out the sum of x first. We have to figure out what z is first, because this is a normal distribution in terms of z. So if you remember, this is kind of like the confidence intervals. We know that the left side of z, in this case, is going to be equal to 0.9. So we got to work backwards. We're given this area, and now we have to figure out what the z value is. Instead of what we did before, we had the z value, and we had to figure out the area. This is the other way around. We have the area, figuring out the z value. And if you remember from the other day, what you want to do is go to your table here, and I've kind of already started it, and you want to look in the table, in this kind of, in all these points, for the number closest to 0.9. Now, as you probably already saw, I found it out. It's going to be, where is it? It's going to be this number right here. So I'll highlight this. It's going to be this number. It's the closest number to 0.9. You're not going to get exactly 0.9 because that would require the table to be a little bit more complex. So this is as close as we're going to get, and you're going to go and look out. So up here and up here. And what we can tell from this table is that if we draw out our points, we're going to have a decimal right here. The first two numbers are going to be 1.2, and the last number is going to be 8 in the 100th spot. And as you can see, I've already kind of figured this out, and that is we're going to get 1.28, which means that if we go back to our normal distribution, this z is equal to 1.28. So what we're essentially saying is that a z value of 1.28 is in the 90th percentile in this normal distribution, meaning that it is greater than 90% of the values. But let's go back to the question. Fix this as well. It's not asking us for z, but it's asking us for the sum of x, which means we have to convert this z value into the sum of x. Now, luckily for you and for me, there's this nice little formula over here we talked about the other day that we can use to convert z to the sum of x. So let's look at what we need to compute this formula. So first we're looking for this, all right, because we don't have that. That's what we're looking for. We have z. We figure that out right down here. We have the sum, or the mean of the sum, which is up here. We did that. It is, the other day, we did that the other day. That's 1,365. Going back to the question, so we've got that. We also have the standard deviation of the sum. And again, going back to our work the other day, we figured that out by doing the square root of n times the standard deviation of the population gives us 62.45. And I should maybe mention, we figured out the mean of the sum by multiplying the number in the sample times the mean of the population. But going back to this, we know that the standard deviation of the sum is 62.45. Where is it? Right here. So we've got z, we've got the mean of the sum, and the standard deviation of the sum, meaning, mathematically, we can figure out what the sum of x is. So let's plug everything in. So let's use purple. So, we know z is 1.28. We don't know what the sum of x is. We know that the mean of the sum is 1,365. And that's all going to be over the standard deviation of the sum, which is 62.45. And the rest is just simple algebra. We're solving for the sum of x, so we've got to multiply both sides by 62.45, which means we're going to get 79.936 is equal to the, oh, that's not good, the sum of x minus 1,365. Add, and now we're going to add 1,365 to both sides. So then we're going to get the sum of x is going to be equal to 1,444.936. Perfect. And this is our final answer here. And looking back at the question we were given, it said find the 90th percentile for the sum of 39 ages. If you wanted to write a word answer for this, you could say the 90th percentile for the sum of 39 ages is 1,444.936. I hope that makes sense. Let me know if you have any questions, and I hope you have a wonderful rest of your day.